What lies at the center of a black hole? The answer could change everything we know about the universe. A team of scientists led by Enrico Rinaldi has used quantum computing to explore the mysteries inside black holes. Their study is based on the holographic principle, suggesting particles and gravity are equivalent but in different dimensions. In a black hole, gravity exists in 3 dimensions, while particle physics operates on its 2-dimensional surface. This means a black hole's massive mass distorts space-time, creating gravity that links to particles gyrating above it. Some scientists believe our entire universe could be a holographic depiction of particles, offering a quantum explanation of gravity. Rinaldi explains that Einstein's general relativity and the standard model of particle physics have been difficult to reconcile. Their recent study, published in PRX Quantum, uses quantum computing and deep learning to investigate holographic duality. By solving quantum matrix models, they hope to gain insights into gravity-related phenomena. These models, though simple, possess attributes of more complex ones used to describe black holes. Understanding the ground state of these models is crucial, as it reveals the fundamental properties of the system. Rinaldi compares the numbers in matrix models to grains of sand, where a level surface represents the ground state. Quantum circuits, depicted as wires with qubits, help smooth out the ripples in the sand. These circuits transform qubits step by step, aiming to reach the ground state, much like playing a piece of music correctly. The team used a neural network to determine the ground state, optimizing parameters iteratively. Despite the limited number of qubits in current quantum hardware, they successfully found the ground state of 2 matrix models. This breakthrough offers a new way to understand the structure of black holes and their event horizons. Major components of black holes include the singularity, event horizon, photon sphere, and accretion disk. The singularity is a point where gravity is so intense that spacetime is infinitely curved. The event horizon is the point of no return, beyond which nothing can escape the black hole's pull. This research is a crucial milestone towards realizing a quantum theory of gravity, opening new doors to understanding our universe.